In this video, I am going to explain about the drift velocity and relaxation time. So what is the drift velocity here? Before going to explain this, we go to the relaxation time. So what is relaxation time? In most of the competitive exams, it will be asked, it is relaxation time. Here the average time that an electron spends between the two collisions is called as relaxation time. There are between two collisions of electron is called relaxation time. When an electric field is given to the any of the wire, so that the free electrons which start accelerating towards the positive terminal, when they accelerates, they will collide again and again with positive ions of the metal. Each collision destroys extra velocity gained by the free electrons. Whenever they collide with the positive terminal, whenever they collide with the positive ions of the metal, they always change their direction from one direction to another direction. So the collision between the average collision between any of the electron is called as relaxation time. The free electrons are continuously accelerated by the electric field here. Okay, the collision prevents their velocity from becoming large. Okay, whenever they collide each other, the velocity of that electron will going to decrease. That results in electric field provides a small constant velocity towards positive terminal. Okay, uh, what is drift velocity here? The average velocity with which free electrons get drifted in a metallic conductor under the influence of electric field is called drift velocity. This is represented by Vd. What is this drift velocity? The average time or the average velocity with which free electrons get drifted, means moved in metallic conductor under the influence of electric field, that is called drift velocity. That is in the free electrons drift velocity, that is in the order of 10 to power minus 5 approximately. What about the relaxation time? Relaxation time is 10 to the power minus 14 seconds, and it is 10 to the power minus 5 meter per second, that is drift velocity. Thus, when a metallic conductor is subjected to an electric field, free electrons move towards the positive terminal of the source with drift velocity. It is very small through it. The drift velocity entirely responsible for electric current in the metal. This is about the relaxation time and the drift velocity. So now I am going to explain about the relation between current and drift velocity. Relation between current and drift velocity. Let us consider some portion of the copper wire here. This is the copper wire, I can say. The current flowing is I. Let us consider some portion here. Okay, I see some portion from here to here. Current I is flowing through it, and copper wire is under the influence of electric field. A is area of cross section. This is A, area of cross section. N is number of free electrons per unit volume is charge on each electron, and Vd is drift velocity of free electrons. Okay, in 1 second, all these free electrons within a distance of Vd to the right of cross section, this is P, right of cross section at P, will flow through the cross section at P as shown in the figure. This volume contains NaVd electrons and charge NaVd into E. Okay, so I can represent this as current I is equal to NeaVd. Since A, N and E are constants, so I can say I is directly proportional to the drift velocity. Hence, we can say the current flowing through a conductor is directly proportional to the drift velocity of the free electrons. So here some important point needs to be considered. The drift velocity of an electron is very small, since the number of free electrons in the metallic conductor is very large. Even small drift velocity of free electrons gives rise to sufficient current. And what about the current density? Then what about the current density here? J is equal to I by E, that is NeAVd divided by A, that is equal to NeVd. The unit of this is ampere per meter square. Current density is a vector quantity, so that the symbol is vector J, that is equal to NeVd only. It is in terms of ampere per meter square.